This video is a Key Stage 4 guide to the idea of terminal velocity. So our title today is Terminal Velocity. Our learning objectives are that we should be able to describe the motion of a falling object affected only by gravity, describe the motion of an object affected by gravity and drag, describe the forces acting on a skydiver and their resulting motion, and finally state what is meant by terminal velocity. So we'll write out our notes in the Cornell note-taking style. We'll write terminal velocity across the top. On the left, in a large margin, we'll write our learning objectives, and in our notes we will answer those learning objectives. Finally, we will summarize what we've learned in our own words. So we'll start with the equation. The weight of an object is equal to its mass multiplied by the gravitational field strength. So, if we have an object that is only affected by gravity, the only relevant force will be its weight. When that happens, the acceleration of the object, given the constant force and constant mass, will also be constant. That is to say that an object acting only under gravity will constantly accelerate. It will never stop accelerating unless another force acts upon it, such as when it hits the ground. However, if we look at a situation where more than one force acts upon the object, in this case, the person jumping out of the plane currently is only affected by the weight. There is no drag because the person is not yet falling. They're not yet moving. So at this point, the person will begin to accelerate downwards. Once that person begins to fall, we find that we have the weight, but because they're traveling at a high velocity, they will also have drag acting on them. In this case, the drag is air resistance. Just after the person's jumped out of the plane, the drag will be small because the velocity of the person is small. However, after some time of accelerating due to a resultant force downwards, the velocity will increase until the point at which the drag and the weight are the same. This means that the resultant force on that person will now be zero because the weight and the drag cancel. At this point, we've reached terminal velocity. That means that the person will no longer accelerate because the force of weight is equal to the force of drag. Then, once the parachute opens, because the person is traveling extremely fast, their drag will be extremely large when the parachute opens. In this case, the drag is greater than the weight at the moment the parachute opens. This will cause them to accelerate upwards. In other words, they will slow down in their motion. They were falling towards the ground, but with greater drag than weight, they're going to slow down. Finally, as they slow down, the drag will decrease. As the drag decreases, eventually the weight and the drag will be equal and opposite, which means the resultant force acting on the object is now zero. In this case, there will be no more acceleration. That means that they will travel downwards with a constant velocity. Again, this is another terminal velocity.